Hello students, welcome to chemistry classes. So under this P block elements, now we are going to discuss some important trends in group 13 elements. So far we discussed the chemical reactivity and nature of compound formation in group 13 elements. So what are the important aspects we are going to discuss is, first one is formation of hydrides. The boron family elements, most of the boron family elements form hydrides with general formula EH3. E is the boron family members, either boron, lithium, boron, aluminium, gallium, indium, etc. The thermal stability of these hydrides decreases as we move down the group. First of all, boron form hydrides with general formula BnHn plus 4 or BnHn plus 6, etc. These boron compounds, especially B2H6, B4H10, B5H11, these compounds associated with special multi-centered bonds. Among these boron hydrides, the diborane B2H6 is very important compound. Aluminium forms hydrides of AlH3n times. AlH3n times. These aluminium hydrides are weak acids. It reacts with bases to form a complex reducing agent or complex hydride compounds. Why these compounds readily form complex hydrides? Because of the vacant of p orbitals. The aluminium hydride compounds, the vacancy of p orbitals, so it reacts with simple bases to form strong reducing agents. The important complex hydrides are lithium aluminium hydrate, lithium gallium hydrate, and lithium gallium hydrate. So these are strong reducing agents. How this lithium aluminium hydrate is prepared? Lithium hydride reacts with aluminium chloride in the presence of ether. It gives lithium aluminium hydride and lithium chloride. Thus, lithium aluminium hydrate is white crystalline solid. This is completely soluble in diethyl ether. It is a powerful reducing agent in the organic chemistry. Okay. The second trend is formation of halides. All the boron group elements readily combines with halogens to form halides of general formula EX3. For example, boron trifluoride, boron trichloride, boron tribromide, and boron triiodide. Halides of borons are covalent in nature and they are exist as monomeric in gas phase. Among these boron halides, boron trifluoride and boron trichloride are gases. Boron tribromide is liquid while boron triiodide is solid under normal conditions. These compounds not obey the octet, or the boron does not obey the octet rule, and it behaves as Lewis acids. These compounds are electron deficient compounds because therefore they are behave as Lewis acids. It readily combines with bases to form an adduct compound. Especially the coordinate covalent compounds are formed with the help of this boron halide compounds. It reacts with or it combines with amino compounds or this ammonia, this ammonia, nitrogen containing lone pair of electron. This nitrogen readily donate the lone pair of electron to boron trifluoride to form an adduct, Lewis acids and Lewis bases. The relative acidic strength of this boron halides are in this order: boron trifluoride, boron trichloride, boron tribromide and boron triiodide. Aluminium halide compounds, especially aluminium chloride, is exist as dimeric in nature. Dimeric in nature. Two aluminium trichloride molecules combines together and exist in the form of Al2Cl6, the dimeric form of aluminium trichloride. Among this anhydrous aluminium trichloride is covalent in nature, while the hydrated aluminium trichloride is ionic in nature. Aluminium trichloride readily reacts with or hydrolysis with water or exist in the form of complex Al H2O6 times hexa aqua aluminate 3 ion, hexa aqua aluminate 3 ion and chloride ion. All the elements of the group 13 form hydroxides and oxides. Especially the oxides of general formula E2O3 and hydroxides of general formula EOH thrice or EOH. Boron readily reacts with oxygen, it gives boron trioxide B2O3. Aluminium reacts with oxygen, gives aluminium trioxide. This oxides are obtained or oxides, these oxides are readily reacts with bases. Sodium hydroxide gives sodium metaborate and water. Boron hydroxide reacts with sodium hydroxide, it gives sodium metaborate and water. The hydroxides are obtained generally dissolving the oxides of the element in water. Boron does not react with boron oxide does not react with water even in the form of steam. The basic character of oxides and hydroxide decreases from aluminium to thallium. The oxides and hydroxides are boron are weakly acidic in nature. And aluminium trioxide reacts with acids. Aluminium oxide is amphoteric in nature, therefore it readily reacts with acids and bases. So this sulfuric acid, corn sulfuric acid, it gives aluminium sulfate and water. Aluminium sulfate and water. Aluminium oxide reacts with sodium hydroxide, gives sodium aluminate. Similarly, aluminium hydroxide reacts with sodium hydroxide, gives sodium aluminate. Aluminium hydroxide also reacts with hydrochloric acid, it gives aluminium trichloride. So from this we must know aluminium hydroxide and gallium hydroxides are amphoteric in nature. Indium hydroxide and thallium hydroxides are basic in nature. Thallium exists as two forms of hydroxide, TLOH thrice and TLOH. The TLOH thrice, thallium trihydroxide, is insoluble in water, but this compound is readily soluble in water. By concluding the oxides and hydroxides of group 13, this oxide forms boron trioxide, aluminium trioxide, gallium oxide, indium oxide and thallium oxide. This hydroxide form. So these two oxides and these hydroxides are acidic in nature. These compounds are amphoteric in nature. These compounds are basic in nature. Okay. So these are some trends in these oxides and hydroxides. The last property is the behavior of compounds. Except boron, trichlorides, tribromides, triiodides and these fluoride compounds are hydrolyzed with water. They are exist MOH 4 times minus and MH2O 6 times 3 plus in the aqueous medium. So this MOH 4 times minus is tetrahedral in geometry, while this compound is octahedral in geometry. They are exist as such type of species in aqueous medium. Aluminium sulfate possesses greater tendency to form double salt, especially alums. For example, it forms alums with potassium sulfate, aluminium sulfate, 24 molecules of water. Potassium sulfate, aluminium sulfate, 24 molecules of water. This alum is a double salt. It is used to purification process, especially is a minute dissolved contents present in the corporation water. It is purified with the help of adding certain amount of alum, that is the potash alum. Softening process and moderning, dyeing, calico printing, as well as this paper industry, the alum is highly useful. The +1 oxidation state is more stable for gallium to thallium. The compounds gallium to thallium, they are exist as +1 oxidation state is highly stable. Even the halide compounds are also known. So this thallium 1 compounds are highly stable. So far we discussed the important trends in group 13 elements. These concepts are very important in the examination point of view as well as NEET and JEE. If you have any doubts, you may ask. Thank you.